Find the electric field at a point that is 2 meters to the right of a 4 nanocoulomb point charge. Also, find the force on a negative 3 nanocoulomb test charge located at that same point. So first, mag-drawing tayo, no? Actually, hindi mo naman kailangan mag-drawing eh, no? Kasi kung alam mo ang formula, rekta na yan sa calculator. Pero syempre, sa mga nagsisimula pa lang matuto, no? Mas maganda na organized yung ating solution. Lagyan natin ng illustration, okay? Halimbawa, ito yung source charge, no? Ang magnitude niya ay 4 nanocoulombs at siya ay positive. Lagyan natin dito 4 nanocoulombs, 'di ba? Tapos meron daw tayong point 2 meters to the right. For example, ito 'yon, no? This point is 2 meters. Ano daw ang electric field dito? To get the electric field, of course we know the formula, right? E is equal to K Q over R squared, no? Kasi nakapag-derive na nga tayo ng formula para sa point charge. Hindi ka na babalik sa definition, no? This is the appropriate formula for this problem because this involves a point charge. Okay. Now, maglagay tayo dito ng values. Ano ba ang value ng K? That's the electric constant. Yan yung 9 times 10 to the 9. Tapos yung Q ay 4 nanocoulombs. So, 4 times 10 to the negative 9 divided by the square of the distance. So, 2, tapos i-square lang natin yan. Now, kung mapapansin mo, magkakancel itong to the 9 at saka to the negative 9. So, ang matitira na lang 9 times 4 divided by 2 squared, which is also 4. So, 4 over 4, makakancel yung 4. Ang matitira na lang is 9. Okay? Kaya naman, ang electric field at this point is equal to 9 newtons per coulomb. Okay? Yan ang magnitude. Pero, pasaan yung direction ng electric field? Kung gusto nating malaman ang direction ng field, aalamin mo lang kung ano yung source charge. Di ba positive yan? And remember that electric fields are directed always away from positive charges. Ayan. So, kung positive, away dapat. So, this is the direction of the electric field at this point. Naiintindihan po ba? Yes. Madali lang yan. Okay? Madali lang. Now, may dagdag na tanong dito. Ano daw yung force doon sa negative 3 nanocoulomb test charge? So halimbawa, maglagay tayo dito ng negative 3 nanocoulomb na test charge. Gagamit pa ba tayo ng Coulomb's law para malaman yung force? Hindi na. Bakit? Kasi nga, meron tayong formula na ang force na nararamdaman ng isang charge due to the presence of an electric field is equal to Q times E. 'Di ba? Ano yung charge na nakakaramdam ng force? Yun, ano? Negative 3 nanocoulombs. So, kung magnitude lang, gawin lang nating 3 nanocoulombs yan. Ano? 3 nanocoulombs at i-multiply natin siya ng electric field na 9 newtons per coulomb. Okay? So, dito may makukompute tayong 3 times 9 which is 27. Diba? 27 times 10 to the negative 9 newtons. Bakit? Kasi nga force yan. So, ang unit niyan, newtons. Or pwede na lang nating sabihin na 27 nanonewtons. Okay? So, yan ang magnitude ng force na nararamdaman ng negative 3 nanocoulombs. Pero, pasaan ang direction ng force? Remember, if this charge is negative, it always experiences a force opposite that of the field. Kaya ito yung direction ng force na nararamdaman niya. Opposite. Again, bakit opposite? Kasi siya ay isang negative na test charge. Let us solve the next problem. A point charge Q equal to negative 8 nanocoulombs is located at the origin. Find the electric field vector at the point x equals 1.2 meters and y equals negative 1.6 meters. So to solve this problem, it would be better if we can first illustrate the problem. Maglagay tayo dito ng x at saka ng y-axis para meron tayong reference. Tapos doon daw sa origin, mayroong point charge. Ito yung point charge natin na may magnitude na 8 nanocoulombs at siya ay negative ang charge, 'di ba? Ilagay din natin yung point na 1.2 at saka negative 1.6. So, positive x, negative y, this must be in quadrant 4. Ito siya. Okay? So, this is the point kung saan gusto nating masukat ang electric field. Diba? Tapos, lagyan natin dito ng line segment connecting the point charge and this point para magkaroon tayo ng distance na r. Okay? Since this is a negative charge, the electric field at this point must be directed towards the point charge. So, i-drawing natin yan. Ito yung electric field, di ba? Negative, kaya directed towards the source charge. Ang hinahanap kasi natin ay electric field vector. Ano? So, hindi pwede na magnitude lang. Kaya, maglalagay tayo ng unit vector para i-indicate yung direction ng electric field. Ito yung unit vector natin na AR. Okay? Sir, saan po galing yung unit vector na AR na yan? Yan ay galing dito sa vector na R. I-divide mo lang siya ng absolute value niya. Remember that the unit vector AR is equal to the vector R divided by its absolute value. Okay? So, mamaya, gagawin natin yan. Pero, bago natin ituloy ang solution, maglagay muna tayo dito ng mga coordinates. Ano ang coordinates ng point charge? It is at the origin. So, 0, 0 yan. Tapos, ano ang coordinate ng point na ito? It's 1.2, negative 1.6. Sir, bakit natin inilagay yung coordinates? Kasi kailangan natin yan sa pag-compute ng unit vector para hindi na tayo gumamit ng sines at saka cosines. Okay? So, what is the formula for finding the electric field of a point charge? E is equal to K Q over R squared. Pero ang kailangan natin ay vector field. So, lagyan natin ng arrow, no? AR. Okay. So, what is the value of K? K is 9 times 10 to the 9. Lagay natin dito ha. E equals yung K. We have 9 times 10 raised to 9. Lagay natin siya sa loob ng parenthesis. Tapos, yung Q natin is negative 8 nanocoulomb. So, isasama natin dapat yung sign ng charge. When we are doing vector calculation of electric field, we always include the sign of the charge, negative 8 nanocoulomb. So, times 10 to the negative 9. Okay? Divided by R squared. No? Ano ba yung distance mula origin hanggang 1.2 at saka negative 1.6? We can use the distance formula to solve for this R. Pero naka-square siya. Diba? Sa distance formula, may square root. Pag in-square natin, matatanggal lang yung square root. Kaya ang matitira dyan is yung 1.2 minus 0, which is 1.2. 1.2 squared plus negative 1.6 minus 0. That's negative 1.6 squared. Okay. Tapos, multiply natin yan ng unit vector. So, yung unit vector, ganun din. Difference lang din. So, 1.2 minus 0, that's 1.2. 1.2. And that is in the direction of the x-axis. So, AX. Then, negative 1.6 minus 0 is negative 1.6. Pero this time, in the direction of the y-axis. Kaya AY. Diba? Tapos divide natin siya. No? Ano ba ang absolute value ng vector na ito? Okay, ito 'yon, no? This R bar is this expression here. 'Yun yung ating displacement vector. Tapos yung absolute value niya, edi square root lang siya ng 1.2 squared plus negative 1.6 squared. Okay, tapos lagyan natin ng bracket dito. Okay. So, pwede na natin yung computein sa isang calculator. 'Di ba? So, the vector electric field can be computed. Pero pwede tayong mag-simplify dito. Ano? Paano tayo magsisimplify? Sa calculator, kahit hindi mo napindutin yung times 10 to the 9 at saka times 10 to the negative 9. Okay? Kasi nga po, magka-cancel lang sila. So, sa calculator, uunahin natin yung para sa AX. 'Di ba? So, that's 9 times negative 8 divided by 1.2 squared plus negative 1.6 squared times 1.2 over this expression. Okay? So, gawin natin yan sa calculator. First, fraction sign. Ano? 9 times negative 8 divided by 1.2 squared plus, tanggalin ko na lang yung negative sign ha, para madaling pindutin kasi same lang naman yung sagot. 1.6 squared times, parenthesis uli, para sa AX, 1.2 over the square root of 1.2 squared plus 1.6 squared. Okay, let's press the equal sign to get the answer. We got negative 10.8. So, sulat natin yan ha. negative 10.8 AX. Okay, now balikan lang natin yung tinype natin sa calculator. Ang magbabago lang doon is yung 1.2. Papalitan natin ng negative 1.6. Okay, so replay lang natin yan. Tapos palitan natin itong 1.2, gawin nating negative 1.6. So makukuha tayong sagot. Yan, positive 14.14. So kopyahin lang natin dito, plus 14.4 AY. So this is the vector electric field at this point. Lagyan natin ng unit, newtons per coulomb. Okay? So let us evaluate, no? Kung kukumputin lang natin yung magnitude ng electric field, so computin natin ha, kq over r squared lang yan. So that's 9 times 10 to the 9 times 8 divided by ito 1.2 squared plus 1.6 squared. So, ang magnitude is 18. Okay? 18 nanocoulombs. Lagay natin dito. The magnitude of the electric field is 18 newtons per coulomb. So, kapag kinuha na natin ng absolute value or magnitude itong vector na ito, dapat ang makukuha nating sagot 18 newtons per coulomb din. Diba? Otherwise, mali yung sagot. Okay? So, check natin. Ano ang magnitude ng vector na to? 10.8 squared plus 14.4 squared. Okay, dapat 18. Ayan, so 18. So, that means tama yung ating sagot. Diba? Na-prove natin na pag ang kinompute lang natin is yung magnitude, may sagot tayong 18 newtons per coulomb. Now, yung nakuha nating vector electric field, kung kukunin natin yung magnitude niya, dapat same lang din sa sagot natin na 18, which is correct. O, diba? Madali lang. Kung babalikan natin itong vector na ito, di ba meron siyang dalawang components? Ano ang dalawang components niya? Yung vertical component at saka horizontal component. For example, this is the vertical component. Positive. Ito, positive siya. Tapos, meron din siyang horizontal component. Alin yon? Ito yung horizontal component niya. Ayan, directed to the left. So, it's negative. So, tama kasi negative yung nakuha nating x component dito. Diba? So, our answer actually agrees with the diagram na ginawa natin kanina. Kaya, confident tayo sa ating sagot. No, maliban na lang again kung nagkamali ka ng pindot sa calculator. Okay? But if you are careful enough, then most likely makukuha mo yung tamang sagot. Ano? So, careful lang tayo pag nagsosolve ha. Practice din para kapag ikaw ay sanay na, hindi ka nagkakamali sa pagpindot sa calculator. Okay? Let us solve another problem. Point charges, so dito meron tayong dalawang charges na given. Yung Q1, positive 12 nanocoulomb at yung Q2, negative 12. So kung matatandaan natin, anong tawag sa kanyang configuration ng charges? Same ang magnitude pero opposite ang polarity. We call this configuration a dipole, di ba? This is an electric dipole. So we have a dipole here. One is located at the origin and the other is located at this point along the x-axis, which is 10 centimeters away from Q1. So nabanggit naman dito, ayan, 0.1 meters apart daw sila. Compute the net electric field caused by Q1 and Q2 at the points A, B, and C. Ayan, meron tayong tatlong points dito ha, A, B, at saka C. Ano daw ang electric field sa tatlong points na yan? So, at each point, dalawa ang nagiging cause ng electric field. Ano? Meron tayong Q1 at saka Q2. Unahin natin yung electric field at point A. So, at point A, two electric fields are being felt. One is due to Q1 and the other is due to Q2. So, isa-isahin natin yan. Ano ang itsura ng electric field at point A due to Q1? Since Q1 is positive, dapat ay away. So, ito siya. Ayan. Pula yung ginamit ko kasi pula din naman siya. Ano? Now, at the same point, ano naman ang electric field due to Q2? So, mas malapit yung Q2, di ba? Sa point A. Kaya, in-expect natin mas malaki yung electric field niya. So, gagamit ako ng panibagong color. Halimbawa, blue yung gamitin ko kasi blue siya eh. Di ba? So, since yan ay negative, dapat ang electric field ay papunta sa kanya towards negative. So, ito siya ngayon. Yan. So, yung red, yun ang electric field due to Q1. And yung blue, this is the electric field at point A due to Q2. And these electric fields are in the same direction. Diba? So, if these two are in the same direction, we simply add the two electric fields to get the resultant electric field at point A. Gawin natin yan ha. The electric field at point A is just the sum of these two electric fields. Why? Because the electric fields are collinear and they are in the same direction. Kaya i-add mo lang sila. Ano? So, ano ang electric field at point A due to Q1? So, since point charge yan, gamitin natin yung formula ng electric field ng point charge. That's K and then Q1 over R1 squared plus K ulit, this time Q2 over R2 squared. So, erekta na natin yan sa calculator ha. Common naman yung K. So, para madaling pindutin sa calcu, isa na lang, no? 9 na lang. Hindi ko na pipindutin yung times 10 to the 9. Kasi nga po, yung dalawang charges na given ay nano. To the negative 9, so makakancel din sila. Tapos, parenthesis na lang. Times, parenthesis. Ang matitira dito yung Q1 over R1 squared. Magnitude lang ang kukumputin ko dito ha. Magnitude lang. Kaya, yung Q1 positive 12. 12 na lang. Gaano kalayo yung Q1 dun sa point A? 6 cm. Pero dapat convert natin yan into meters. So, 0.06. Then, squared. Okay? Plus, yung Q2. Yung Q2 negative. Pero again, magnitude lang ang ating kinocompute. Pag magnitude, i-disregard na yung sign. Bakit? Kasi nga, yung direction nila, naka-indicate na dito. Ayan, no? Pareha silang to the right. 'Di ba? 12 na lang divided by gaano kalayo ang Q2 sa point A, 4 cm. 0.04 squared. Okay. Close parenthesis equals. And the answer is we have 97,500 or 97.5 times 10 to the 3. 97.5 times 10 raised to 3 newtons per coulomb. Okay? At kita natin, yung electric field na yan, ano ang direction? It is directed to the right. So, pwede natin gawin na vector yan, di ba? The electric field at point A, the vector field is equal to 97.5 times 10 raised to 3. Lagyan natin dito ng direction, unit vector AX, newtons per coulomb. Okay? So, again, this unit vector indicates that the electric field is along the x-axis, positive, so that means to the right. Okay? Now, compute naman natin ang electric field at point B. Ito yung point B. Sa point B, ang electric field na nararamdaman ay due to Q1 and Q2 pa rin. Dalawa pa rin sila. Ano ang itsura ng electric field at point B due to Q1? Away. So, dapat pakaliwa. Mahirap mag-drawing pakaliwa, kaya pakanan. Pero yung arrow, pakaliwa pa rin. Okay. So, ito yung electric field due to Q1. No? Gawin naman nating blue, yung electric field due to Q2. Since mas malayo yung Q2, mas maliit yung electric field niya. Pero siya ay negative. So, dapat towards it. Ayan. Okay. So, mas maliit yung electric field kasi mas malayo yung Q2. Bakit sa pakanan? Kasi po ito negative. The electric field must be drawn towards the negative charge. So at point B, itong dalawang electric fields na ito, magsusubtract sila. Right? Merong pakanan at merong pakaliwa. So ang ginagawa dyan ay dinatural, yung positive is yung pakanan at negative yung pakaliwa. 'Di ba? So we have, itong electric field na ito ay due to Q2. Right? At itong electric field na ito due to Q1. So yung electric field due to Q1, that's negative, right? So, negative K times Q1 over R1 squared. Tapos, ito namang para sa Q2, positive kasi pakanan, plus K times Q2 over R2 squared. Okay? Again, erekta na natin yan sa calculator, ha? Ayan. Common factor ulit yung K, so 9 na lang, times parenthesis, fraction sign. Yung una negative kasi yung direction niya siya ay pakaliwa, 'di ba? So indicate natin yon negative of Q1 which is 12. Gaano kalayo yung Q1 mula sa point B? That's 4 centimeters. Kaya 0.04 meters yan squared. Para naman sa pangalawang charge, Q2 over R2 squared. Fraction sign, Q2 is 12 divided by gaano kalayo yung Q2 mula sa point B? This is 10. 10 plus 4 is 14. So, 14 cm is 0.14 meters. Okay? Tapos, i-square natin yan. And then, close parenthesis equal sign. Ang sagot, We have approximately negative 62, di ba? Lagay natin dito, negative 62 times 10 raised to 3 newtons per coulomb. So, sir, kung negative ang sagot natin, ano ang ibig sabihin yan? Kung negative, ibig sabihin yan ay directed towards the left. So, kung gusto mong gawing vector yan, the vector electric field at point B is equal to negative 62 times 10 raised to 3 AX newtons per coulomb. Again, the negative sign indicates that the direction of the electric field at point B, the net electric field must be to the left. Okay, kita naman natin dito eh, 'di ba? Mas malaki yung to the left kumpara sa to the right. So pag sila ay nag-add, mananalo yung to the left kasi mas malaki siya. Now, let us solve the electric field at point C. No? Kung point C na ang pinag-uusapan natin, hindi nagagana yung simpleng addition at subtraction. Bakit? Kasi po, ang electric field at point C ay hindi na kolinyar. Diba kanina kitang-kita natin yung electric field at point A, kolinyar. No? At dito, kolinyar din. Pinagkaiba lang, opposite yung direction, kaya nag-subtract sila. Diba? But at point C, yung electric field natin, they are no longer kolinyar. Sige, drawing natin. Ano ang itsura ng electric field at point C that is due to Q1? So, since Q1 is positive, dapat away. Ito siya. Ayan. Tapos, yung electric field at that same point due to Q2, negative. So, kung negative, that's towards. Okay. Now, alam natin na yung Q1 at Q2, same lang ang magnitude. Ayan, 12. Kaya, dapat magkasing haba yung arrow. Diba? Ayan. Okay. Meron tayong electric field due to Q1. Lagay natin dito. At electric field due to Q2. So, noting the fact that Q1 and Q2 have the same magnitudes, edi dapat yung component ng E1 at saka ng E2 along the y-axis ay magka-cancel. Bakit? Kasi equal yung y component nila, no? Yung isa pataas, yung isa pababa. Because we know that this electric field has an X component and a Y component. Likewise, this E2 has an X component and a Y component. And because again, these two charges have equal magnitudes. And at the same time, yung distance nila sa isa't isa ay parehas na 13 centimeters. Yung electric field dito dapat parehas din. Pero yung direction nila magka-opposite, di ba? Kaya, yung Y components nila magka-cancel. So, ano na lang ang expect natin dito? Ang expect natin is that ang matitirang electric field sa point C ay yung horizontal component na lang. Yung horizontal component ng E1 at saka horizontal component ng E2 ay mag-a-add up kasi parehas silang pakanan. So, ito ngayon, ang electric field at point C. Okay? So, pag tayo nag-compute, dapat ang matira na lang is yung AX component. Okay? Tingnan natin kung mangyayari yan. Sir, paano natin yan gagawin? So, dito, gagamit na tayo ng vector addition. Ano? So, kung vector addition yan, dapat yung electric field at point C ay equal sa K Q1 over R1 squared. Lalagyan natin ng AR1, di ba? Plus K Q2 over R2 squared tapos AR2. Okay, again, gagamit na tayo dito ng unit vectors to indicate the direction of E1 and E2. So, sulat natin. Madali lang yan because it's easy. Easy. Okay. So, yung K, common factor naman yan, di ba? K. Tapos, lagyan ko lang dito ng bracket. Yung Q1 natin, 12 nanocoulomb. So, since ito ay vector calculation, dapat isasama natin yung signs, ha? So, positive 12 nanocoulombs. So, 12 times 10 raised to negative 9 over, gaano ba kalayo yung Q1 sa point C? Di ba 13 cm? So, dapat yan ay 0.13 squared. Lagyan natin ng unit vector. Sir, paano nga gawin yung unit vector? To do that, kinakailangan malaman muna natin yung coordinate ng point C. Okay? Ang point C ay nandito sa point na ito. Ano ang value ng X dito? Since ang triangle na ito ay isosceles, kasi 13 at 13 yan, that means itong C ay nasa gitna. Mula dito hanggang dito ay 10 cm. So, ang gitna nun is 5 cm. Lagay natin dito, 5 cm yon. So, 0.05. Diba? Ano naman ang kanyang Y component? Makukuha natin yan kasi pwede tayong gumawa ng right triangle dito. Okay? So, ito 13. Ito 5 at ito yung Y component na hinahanap natin. Diba? So, that's just the square root of 13 squared minus 5 squared. Pag kinumpute mo yun sa calculator, that's 12 cm. Okay? So, 0.12 yung ilalagay ko dito. 0.12. Meron na tayo ngayong coordinate ng point C. Lagyan naman natin ng coordinates yung Q1. So, nasa origin siya, kaya dapat ang kanyang coordinate ay 0, 0. At itong Q2, ang coordinate niya ay, ang x component niya ay 10 cm. So, 0.1. Tapos, ang y component niya ay 0. Ayan. Meron na tayong coordinates. Kaya makakakuha na tayo ng mga unit vectors. Okay? For EC, ano yung unang unit vector natin? So, that's 0.05 minus 0. So, 0.05 AX. Next, 0.12 minus 0. So, 0.12 plus 0.12 AY. Tapos, i-divide natin. Ano nga yung distance? Hindi na natin kukumpitin kasi obvious na given sa problem, 0.13. Okay, yan. Tapos, dagdagan natin dito ng plus. Bakit? Para naman dito. Okay? So, yung K nasa labas na yun ha. Ang idadagdag ko na lang is yung Q2 over R2 squared at saka yung AR2. And again, since this is a vector calculation, kailangang isama natin yung sign ng Q2. So, magiging negative 12 yun. Negative 12 times 10 to the negative 9. Divided by, same lang yung distance niya, 13 cm. So, 0.13 squared. Tapos, yung unit vector na AR2. Alin yun? Ito yung unit vector na AR2. So, 0.05 minus 0.1. Diba? That's negative 0.05. Lagyan natin dito ng AX. Tapos, 0.12 minus 0 plus 0.12 AY. Divided by yung distance, again, that's 13 cm or 0.13 meters. Yan, close parenthesis. Tapos, lalagyan natin ng closing bracket doon. Now, bago tayo magpipindot sa calcu, atin mo nang tingnan yung ating mga pinagsusulat dito. 'Di ba? Kung mapapansin mo, equal naman sila, 'di ba? Ayan no, 12, no? Makaka-cancel yung to the 9 dito at saka to the negative 9. Pero dito may negative sign, 'di ba? Yung negative sign dito, anong mangyayari? Ililipat mo lang siya sa sign ng unit vector. Ganun ang practice. So kung ito negative, pag ito binultiply mo dito, anong mangyayari? Ito magiging positive. So tanggalin ko na to dito ha. At ito, magiging negative na siya. 'Di ba? Bakit? Kasi negative times positive, negative. So, tanggalin ko na dito yung negative sign. Ayan. Na kung mapapansin mo, parehas naman sila, 'di ba? Parehas. Ayan, no? 0.05, 0.05, 0.12. Ay! Itong negative at saka positive 0.12 na ito, magka-cancel yan. 'Di ba? So, yung positive at saka negative 0.12 na yan, magka-cancel sila. Ano? Yan ang sinasabi ko sa inyo kanina. Kaya dapat ang matira na lang is yung horizontal component kasi magka-cancel yung vertical component. Na nangyari na nga ngayon. 'Di ba? Amazing! Napapag-connect-connecta natin yung mga nagaganap dun sa problem. So, ganyan talaga kapag ka nagsosolve ka ng problem. Dapat nai-relate mo yung iyong kinocompute dun sa actual situation na meron ka sa problem. So, pwede na siguro tayong mag-compute sa calculator ngayon. Okay? Sa calculator, pindutin natin yung K, pero hindi ko na ilalagay yung to the 9 kasi nga may to the negative 9 sa loob. 9 times parenthesis, tapos fraction sign para dito. 12 na lang divided by 0.13 squared times 0.05 fraction sign uli. Merong 0.13 sa ilalim niya. Tapos ito, 'di ba? Magkamukha lang sila. Kaya ang gawin ko na lang, times ko na lang ng 2. 'Di ba? Para matipid sa effort. Okay. Ito ang nakuha nating sagot ngayon. We're able to get 4.9 times 10 to the 3. The electric field is equal to 4.9 times 10 raised to 3 newtons per coulomb. And that is along the direction of the positive x-axis. Ayan. Kaya ito positive. Okay? So, ito na yun yung vector electric field at point C. Okay? So, vector siya kasi naka-indicate yung direction. It's along the positive x-axis. So, kung gusto mo naman na magnitude lang, tanggalin mo na lang yung AX. Simply, your answer is 4.9 times 10 to the 3 newtons per coulomb. Okay? Di ba madali lang? Bago natin i-solve yung susunod na problem, ilagay muna natin dito sa points A and B yung electric field vectors na nakuha natin kanina. Di ba? Sa A, we have positive. 97.5 times 10 to the 3. So, mas malaki sa point A kumpara sa point B. Tapos sa point B, dapat pakaliwa. Okay? So, ito sa point A, yan. At ito sa point B, mas maliit kumpara sa point A. So, yan yung electric field at point B. This is electric field at point A. And this is the electric field at point C. Okay? So, di ba? Caring nyo lang yan. Kinakailangan lang mag-practice ka para pag ikaw ay praktisado na, hindi ka na nahihirapang mag-solve ng mga problems. Makikita mo na kahit yan ay matrabaho, paulit-ulit lang yung steps. Hindi ka maliligaw dyan. Okay? Sa mga susunod na problems, i-relate naman natin yung topic sa electric field dun sa previous topic natin about mechanics, yung mga natutunan nyo sa Physics 1. So, this is the next problem. We have a water droplet whose mass is very small. Ayan, 3 times 10 to the minus 12 kilograms and is located in the air near the ground during a stormy day. Ayan, stormy day, masama ang panahon. May water droplet na napakaliit. At yung the water droplet na yan ay malapit lang sa ground. So, ibig sabihin, wala siya sa ground. Yes. Ganun na nga, it appears. Bakit kaya? The atmospheric electric field of magnitude, yan, 6 times 10 to the 3 newtons per coulomb. Meron daw electric field which is due to atmospheric effect. Siya daw ay nakaturo vertically downward. So for example, ito yung ground. Meron daw ditong electric field na pababa. Ayan. So, di ba constant yung electric field? So, paano natin i-drawing ang constant electric field? Parallel lines that are equally spaced. Tapos, yung daw electric field na yon ay nasa vicinity ng water droplet. And the water droplet remains suspended at rest in the air. So that means yun palang water droplet na sinasabi dito ay nakalutang. Yes. For example, ito yung water droplet. Yan. Tapos yung water droplet na yan, nakalutang dyan. So bakit siya nakalutang? Lumulutang yan because may nararamdaman siyang force other than the force of gravity. Diba? We know that even though this water droplet has a tiny mass, meron pa rin niyang napakaliit na gravitational force which is actually its weight. Diba? Yun yung mg ng water droplet which is pababa. Pero again, kung yan ay nakalutang, dapat maiisip mo na may isa pang force na kumokontra sa downward force. Kaya siya nakalutang. So, ilagay natin. Halimbawa, ito yung upward force na kumokontra dun sa gravitational force. Now, saan galing itong upward force na ito? Yan. Nakalagay kasi dito, what is the electric charge on the droplet? So, ibig sabihin, may charge yung droplet of water. At kung siya ay may charge, meron tayo ditong electric field, 'di ba? Kapag ka may charge na nakalagay sa isang electric field, that charge always experiences a force. Kaya 'yan, meron tayong upward force, 'di ba? So dito ang electric field ay pababa at ang force na nararamdaman niya ay pataas. Bakit? Kasi nga kinokontra niya yung weight which is due to gravitational force. So kung itong force na to pababa, hindi lulutang yan, 'di ba? Kinakailangan may force na kumontra sa gravitational force para siya ay lumutang. Kaya i-drawing natin na itong force na ito ay pataas. And knowing that this is upward, while the direction of the electric field is downward, kung opposite ang force dun sa direction ng electric field, what can we say about the charge? This charge must be negative, 'di ba? So, nakikita na natin yung kwento dito sa problem na ito. Ngayon, anong hinahanap? Ano daw ang electric field dun sa droplet? Madali lang yan. To get the electric field, we just apply the equilibrium condition. Bakit? Kasi nakalutang siya. 'Di ba? That's why, yung dalawang forces na ito equal sila. Lagay natin the force due to electric field is equal to the force due to gravity. Okay, so pag kinompute natin yan, ano ba ang force due to electric field? Diba? That's Q multiplied by E. Yes. Is equal to the force due to gravity, which is equal to the weight of the water droplet na mg. Yan. So, ang hinahanap natin is yung charge. Makocompute mo na yung charge. That's equal to mg over E. Yan. So, direct substitution lang ito. Ano yung mass ng droplet? 3 times 10 raised to negative 12. Of course, that's in kilograms. The acceleration due to gravity is 9.8 meters per second squared divided by the magnitude of the electric field, which is 6 times 10 to the 3. 6 times 10 raised to 3. Okay. So, yung magnitude ng charge, makukompute natin sa calculator. Fraction sign, 3 times 10 raised to negative 12 times 9.8 divided by 6 times 10 raised to 3 equals, ayan, meron tayong napakaliit na amount ng charge, 4.9 times 10 to the negative 15. 4.9 times 10 to the negative 15. So, this is in coulombs. Ano ba yung engineering prefix para sa negative 15? Di ba? That's femtocoulomb. So, pwede rin natin yung isulat as 4.9 femtocoulombs of charge. So, napakaliit. And we know that, again, this charge must be negative. Okay? So, let us solve another problem. A uniform electric field is directed along the x-axis between parallel charged plates separated by a distance d. Ito yan, ano? Meron tayong dalawang charged plates, yung nasa kaliwa positive, yung nasa kanan negative. Anong itsura ng electric field? Away from the positive towards the negative. Kaya yung electric field ay directed to the right. Uniform yung electric field. Kaya makikita natin parallel yung mga electric field lines and they are equally spaced. Tapos yung dalawang plates, ang distance nila ay d. A positive point charge Q of mass M is released from rest at a point A next to the positive plate and accelerates to a point B next to the negative plate. So ano itsura nun? Halimbawa, ito yung point A. Sa point A, lagyan natin ng charge na ang magnitude ng charge na taglay niya ay Q, sang-ayon sa problem. Ito daw ay released from rest. So, lagyan natin dito, ang kanyang initial velocity dapat ay 0. Okay? Released from rest. Dahil may charge dun sa region ng electric field, siya ay makakaramdam ng force, which will cause it to move towards the right. Bakit? Kasi po siya ay positive. Ang force na mararamdaman niya dapat in the same direction as the electric field. So, ito yung direction ng force. Kaya gagalaw siya ngayon. Papunta sa kanan. Yan. Pag umalaw siya, mararating niya itong point B. Ang tanong, ano daw yung speed ng particle at B? By modeling it as a particle at constant acceleration. Sir, bakit naman tayo nagkaroon ng constant acceleration? Ganito yan. Remember, nakaramdam ng force yung charge. At dahil nakaramdam siya ng force, syempre may acceleration. 'Di ba? So, paano natin malalaman yung acceleration na yan? We know that from Newton's second law of motion, the net force is equal to mass times the acceleration. So, now, the acceleration is equal to the force divided by the mass. Okay? Gaano kalaki yung force na nararamdaman ng charge na yan? Di ba QE? Yes. Divided by the mass. So, ngayon, ito na yung acceleration ng charge na ito. Di ba? Hindi pa tayo tapos. Bakit? Kasi ang hinahanap ay yung speed. Knowing the acceleration and the distance between the plates, paano natin malalaman yung speed? We can use the formulas that we have previously studied in kinematics. 'Di ba? So, kung alam mo yung acceleration at yung distance traveled, pwede mong gamitin yung formula na Vf squared is equal to Vi squared plus 2 AD. Yes. Knowing that this initial velocity is 0 kasi it was released from rest. 'Di ba? Yung Vf, mako-compute na natin ngayon. Vf is equal to the square root of 2AD. Yan. Tapos, yung acceleration kanina, na-compute na natin. That's QE over M. So, palitan lang natin ha. Magiging 2 times QE over M multiplied by D. Yan. So, kung aayusin ko ang pagkakasulat, magiging ano na lang siya? 2QED divided by the mass. So, ayan. May na-derive na tayong formula. This is the formula for finding the final velocity of this charged particle nung dumating siya dun sa point B. Naiintindihan po ba? That's equal to the square root of 2QED over M. Kung saan ang charge ng particle ay Q, yung electric field sa region ay E, at yung distance na na-travel niya ay D. And finally, yung mass ng particle ay M. Sa letter B naman, anong pinapahanap? Actually, yun din. No? Ayan, no? Find the speed of the particle at B. But this time, we'll use energy analysis. Sir, anong ibig sabihin ng energy analysis? Ganito lang yan. Kung energy analysis ang gagamitin mo, di gamit ka ng law of conservation of energy. 'Di ba? Anong theorem ang applicable dito? So, ibalik natin yung charge ha. Halimbawa, ito yung charged particle. 'Di ba? Kapag ka ang isang particle ay naka-experience ng force, syempre, mag-accelerate siya. Pag siya ay nag-accelerate, magbabago ang kanyang velocity. Ayan. Sinasabi ng theorem na kapag ka ang force na naramdaman ng isang bagay ay nagresulta lamang sa pagbabago ng kanyang velocity, natural, magbabago ang kanyang kinetic energy. Di ba? So, gaano kalaki ang pagbabago ng kinetic energy? According to the theorem, the change in the kinetic energy is equal to the net work done on the object. So, that statement is called the work energy theorem. Sulat natin dito ha, work energy theorem, which states that the change in the kinetic energy is equal to the net work done. Ano ba ang formula ng kinetic energy? We know that the kinetic energy is equal to 1/2 mv squared. So, since yan ay change, dapat final minus initial. Common naman yung m, hindi naman magbabago yun. Kaya ilagay natin dito, 1/2 times m final. So, vf squared minus the initial, vi squared, is equal to the net work done. Gaano kalaki yung net work which was done on this particle na nagtataglay ng charge? That's equal to the force acting on the particle multiplied by the distance traveled or its displacement rather. Yan. So, knowing that initially the velocity of this particle is 0, meron na tayong formula na 1/2 m vf squared. Lagay natin dito 1/2 m vf squared is equal to yung f times d. But we know that this f is equal to q times e. 'Di ba? Kaya mula dito sa equation na ito, makukuha natin yung expression para sa final velocity. Sulat natin. The final velocity is, 'di ba, naka-square yan. So, dapat ito, mumultiply ko lang ng 2 at i-divide ko ng m. So, 2qed over m. 'Di ba? 2qed over m. And then, naka-square to. So, kukunan ko lang ito ng square root. That's it. Ano napansin mo? Yung nakuha nating equation ng final velocity, kagaya lang nung nakuha natin kanina, ito square root of 2qed over m. No? Now we have square root of 2qed over m. So, anong ipinapakita ng example na ito? Yan. Itong problem na ito, pwede mo pala siyang isolve using two different approaches. Yung isa, ang approach natin is yung kinematics. No? At yung pangalawa, ang ginamit natin is energy analysis. 'Di ba? So, there are many ways on how to solve a problem. It's up to you na lang kung saan ka mas convenient. So, sa tingin mo, alin ang mas convenient? Yung kinematics na ginawa natin kanina or yung energy analysis na gumamit ng work energy theorem? 'Di ba? So, you have options. You always have options. Okay? Sige, solve natin yung sunod na problem. An electron enters the region of a uniform electric field with an initial velocity of 3 times 10 to the 6 meters per second and the electric field is 200 newtons per coulomb. The horizontal length of the plate is 0.1 meter, so 10 cm yan. Letter A. Ano daw ang acceleration ng electron nung siya ay nasa electric field? And assuming the electron enters the field at time 0, find the time at which it leaves the field. Para ma-solve ito, kinakailangan gumawa muna tayo ng illustration. Ano? So, ito yung dalawang plates. Positive at saka negative. Tapos, meron daw electron na papasok dito sa region ng electric field. Papalagay natin na ito yung electron. Ano? Ang electron, initially, nasa labas. Papasok siya dito sa region na nasa pagitan ng dalawang plates. At kung charged yung plates, therefore, sa pagitan nila, dapat may electric field. 'Di ba? Ito yung electric field dun sa region between the plates. Upward, kasi nga positive to negative. Uniform yung electric field according to the problem. Initially, this electron has a velocity which is directed to the right. Yan. So, yung kanyang initial velocity ay purely in the horizontal direction. Pagpasok niya sa region kung saan may electric field, may mararamdaman siyang force. 'Di ba? And knowing that this is an electron, which is negative ang charge, ano ang mararamdaman niyang force pagdating niya dito sa electric field? No? Yan. Halimbawa, andito na yung electron. Kung negative ang charge niya, makakaramdam siya ng force na opposite sa direction ng field. So, pababa. Yan. At dahil may nararamdaman siyang force pababa, ay di mag-a-accelerate sa pababa. So that means habang gumagalaw siya horizontally, gumagalaw din sa vertically, pababa ng pababa, hanggang sa marating niya yung dulo. Naintindihan po ba? So we can imagine that this electron has a trajectory na para bagang ganito. Ayan. Okay? Ito yung trajectory ng electron. Again, bakit nga po siya bumababa? Kasi habang siya ay gumagalaw horizontally, nakakaramdam siya ng downward force due to the electric field. Ito siya. Ayan. No? Okay. Hanggang marating niya yung dulo. Yan. Pag narating niya na yung dulo, ayan, eto na siya ngayon. Diba? Pero mamaya na yan. O, balik natin sa kanina. Ano muna yung acceleration ng electron habang siya ay nandun sa region ng electric field? Marunong na tayo mag-compute ng acceleration, di ba? The acceleration is just the net force na nararamdaman niya divided by the mass. Now, what is the net force? The net force is the charge of an electron, which is actually constant. Yan yung E na constant sa calculator. Q, ito yung Q niya. Multiplied by E, yung electric field. Okay? And divided by the mass. But this is an electron. So its mass is also a physical constant. So compute natin yan sa calculator ha. Sa calculator, anong constant? Yung electronic charge. That's constant 23. So lagay natin dito, shift, constant 23. That's the charge of the electron times yung electric field, the 200. Divide it by the mass of the electron. So, sa calculator, that's constant 3. 0.3. So, kapag gumagamit tayo ng constants, ang gamitin na natin is yung value sa calculator para pag tayo ay nagko-compute, pare-parehas ang makukuha nating numerical value. Okay? Ayan. May nakuha tayong 3.5 times 10 to the 13. Napakalaking acceleration ito. Pero bago ko muna yan isulat, isave ko muna ito ha. Shift, store A. Bakit sir mo isinave? Kasi gagamitin natin yan sa ating succeeding calculations. Para hindi tayo nagra-round off. Ang gagamitin natin ng numerical value para sa mga partial answers is yung eksaktong sagot sa calcu na hindi nagra-round off. Now, isulat na natin ang sagot. 3.5 times 10 to the 13. Unit, acceleration. So, meters per square second. Okay, napakalaking acceleration yan. So, ina-expect natin yung velocity niya mabilis din. Yes, ayan no. So mag-accelerate pa siya, so bibilis pa siya, 'di ba? Kaya kapag tinanong tayo dun sa letter B, assuming that the electron enters the field at time t equals 0, find the time at which it leaves the field. So mula dito hanggang dun, no? Pag siya ay nakarating dito, dapat mangyari 'yon at a very very short amount of time kasi napakalaki ng ating acceleration, 'di ba? To solve letter B, we need to consider that this electron has two independent motions. Okay? Bakit? Kasi meron siyang initial velocity, di ba? Which is directed to the right. And because of that, it will move to the right at a constant speed. Okay? So therefore, yung kanyang horizontal motion ay uniform ang speed. O lagay natin dito. Horizontal motion has uniform velocity. Ayan, constant ang velocity. Ibig sabihin ng uniform, constant. So, kung constant ang kanyang velocity, ano yung ginagamit nating formula? 'Di ba? The total distance traveled, which is actually yung length nung plate, which is equal to L. Lagyan natin dito, L is equal to the velocity multiplied by the time. So, to indicate that this is along the horizontal, lagyan natin dito ng subscript na X. Now, to solve for the time, T is equal to the distance traveled, L, divided by the velocity along the x-axis. So, this is 0.1 meters. So, 0.1 divided by yung velocity niya. Yan, 3 times 10 raised to 6. Okay. So, pwede na natin computein yan sa calculator. Fraction sign, 0.1. Tapos, divide mo siya ng 3 times 10 raised to 6. Ang sagot, ayan, napakaliit, di ba? 33.3 times 10 to the negative 9. So, that's nano. 33.3 nanoseconds. Sulat natin. 33.3 nanoseconds. So, just like what we expected, yung time para marating yung dulo ng electric field ay napakaliit. nanoseconds lang siya. 33.3 nanoseconds. Pero isave natin yan. Bakit? Kasi gagamitin ulit natin yan sa pagkukompute ng letter C. Ano naman yung tanong sa letter C? Assuming that the vertical position of the electron as it enters the field is yi equal to 0. Ayan. So, initially daw dito, wala pa siyang vertical displacement. Kasi ang initial value ng y ay 0. Ano daw ang kanyang vertical position when it leaves the field? Ayan. So, punta tayo sa next slide. When it leaves the field, andito na ngayon yung electron. Ang itinatanong sa letter C, ano daw yung kanyang vertical position? So, ito ngayon yung y na itinatanong. No? Gaano kalaki ang value ng y? Paano natin malalaman yan? Sa letter C, ang itinatanong ay vertical position. So, dapat ang i-consider natin is yung vertical motion nung electron, 'di ba? And how do we describe the vertical motion of the electron, 'di ba? Doon sa part A, kita natin kanina na siya ay nag-a-accelerate, 'di ba? Ang acceleration na ito actually ay downward. Bakit? Kasi ang force ay downward, 'di ba? O lagyan natin dito, no? The acceleration is equal to 3.5 times 10 raised to 13 meters per square second. Gawin nating vector yan. In what direction? No? Along the y-axis. Pero pababa, kaya negative siya. 'Di ba? Yung kanyang vertical motion ay may acceleration na constant ang value. So, pwede natin ditong ilagay bago tayo mag-solve. Vertical motion has a constant acceleration. And knowing that the acceleration is constant, we can now solve for y. Paano? In our study of uniformly accelerated motion, we know that the distance traveled is equal to vi times t plus 1/2 at squared. Yan. Itong distance na travel na ito, yan yung y. Okay? Palitan lang natin y is equal to itong vi, yan ay yung velocity, initial velocity in the vertical direction. Multiplied by t plus 1/2 at squared. Okay, tanong. Meron bang vertical component ang initial velocity ng electron? Parang wala. Bakit? Kasi kanina, yung initial velocity niya is purely in the horizontal direction. Kaya, we can safely conclude that this initial velocity is 0. So, ang matitira na lang is yung 1/2 at squared. Diba? Y is equal to 1/2 times yung A na negative 3.5 times 10 raised to 13 times yung time na 33.3 nanoseconds. Diba? Yung sagot natin kanina. And don't forget to square. Pero, pag nag-compute tayo sa calculator, ang ilalagay natin is yung sagot natin kanina nakastore sa calcu. Para hindi tayo nag-round, mas accurate yung makukuha nating sagot. Diba? So, 1/2 is 0.5 times yung nakasave kasi sa calculator natin, magnitude lang ng acceleration. Kaya ang ilalagay ko, negative. No? Negative alpha A. Okay? Kasi sa A, nakasave yung 3.5 times 10 to the 13 times B. Bakit? Kasi po, yung time ay doon nakasave sa B. So, this is 1/2 at squared. Okay. And the answer is, ayan, we have negative 19.5 times 10 to the negative 3. Diba? Y is equal to negative 19.5. Yung times 10 to the negative 3, millimeters yan. Yan. Millimeters. Or, gawin na lang nating y is equal to negative 1.95 centimeters para mas malaki, no? Sir, anong ibig sabihin ng negative sign dito? The negative sign only indicates that the final position of the electron is below the initial. Tama, kasi initially andito siya, 'di ba? Yung final vertical position niya is below the initial position. Kaya nag-negative ang nakuha nating sagot. Okay? 'Di ba ang saya? Ako nag-enjoy ako doon, kayo. So, dapat kapag ka nagsosolve ka ng problem, nag-e-enjoy ka rin habang ikaw ay nagsosolve. 'Di ba? Para hindi mo na-feel na ang pagsosolve ng problem ay isang napakalaking burden sa buhay mo. Okay? Kapag happy ka sa ginagawa mo, most likely, yung makukuha mong sagot, tama din. 'Di ba? Next, let us solve the last and final problem for this episode. When the terminals of a battery are connected to two parallel conducting plates with a small gap between them, the resulting charges on the plates produce a nearly uniform electric field between the plates. If the plates are 1 centimeters apart and are connected to a 100-volt battery, the field is vertically upward and has a magnitude of 1 times 10 to the 4 newtons per coulomb. To illustrate that, here is a drawing. Yan, ito yung dalawang plates natin. Positive plate sa ilalim, negative plate sa taas. Tapos ito daw, dalawang plates na ito connected sa terminals ng battery. So ito positive kasi nakakonekta siya sa positive ng battery. At ito naman negative kasi nakakonekta siya sa negative ng battery. Anong itsura ng electric field dito? Ang electric field upward. Kaya ganyan ang pagkakalagay natin. Okay? Para maging upward yung electric field. Gaano kalaki yung electric field? Yung electric field ay 1 times 10 to the 4 newtons per coulomb. Actually, galing lang yan dun sa battery. No? Yung 100 volts, dinivide lang natin ng 1 centimeter. Diba? 100 divided by 0.01, that will give you 10,000, which is this. 1 times 10 to the 4 newtons per coulomb. Next, if an electron is released from rest at the upper plate, ayan, meron daw tayong electron na manggagaling sa upper plate. Ano daw ang kanyang acceleration? Halimbawa, ito yung electron. It is released from the upper plate. Ito yung upper plate, meron tayong electron. Yung electron na yan makakaramdam ng force due to the electric field. And that force is opposite the direction of the field. Kaya, yung force na mararamdaman niya ay pababa. So, mag-a-accelerate sa downwards. Diba? Sabi dyan, if an electron is released from rest at the upper plate, ano daw ang kanyang acceleration? Kanina pa natin sinosolve yung acceleration na yan eh. Diba? Ano yung formula ng acceleration? A is equal to QE divided by the mass. Again, sa calculator, gamitin na lang natin ang mga constants. Yung Q is the charge of the electron which is stored in constant 23 of the calculator. Multiply natin ng electric field. Ang value is, diba, 1 times 10 to the 4 yan. 1 times 10 to the 4. Divided by the mass of the electron, constant 3. Shift, constant 0.3. Okay, ang sagot. Ayan, ang laki. 1.76 times 10 to the 15. 1.76 times 10 to the 15 meters per second squared. Okay, save natin to. Bakit? Kasi baka kailanganin natin yan mamaya sa succeeding questions pa. Next, what speed and kinetic energy does it acquire while traveling 1 centimeter to the lower plate? Diba parang kagaya lang yun ng problem kanina. Itinanong sa atin yung speed. Diba? Pwede natin gamitin yung kinematic equation na Vf squared is equal to Vi squared plus 2AD. Ang final velocity ay equal sa square root ng 2AD. Right? Gawin natin yan sa calculator. Rekta na. Square root of 2 times yung acceleration na ka-store sa A ng calculator times yung distance traveled is 1 cm. 0.01 meters equals, ayan, ang final velocity niya ay 5.93 times 10 to the 6. 5.93 times 10 to the 6 meters per second. Napakabilis nun. So, kung napakabilis niya, mararating niya itong lower plate in a very, very short amount of time. Mga nanoseconds din yun. Diba? Pero bago natin hanapin yung time, itinatanong din dito yung kinetic energy na kanyang na-acquire. Yung kinetic energy ay di 1/2 mv squared. Ang velocity niya, nung narating niya yung baba, is ito. Kaya, makukompute na natin yan. Okay? Shift, store B. Store natin ha. So, 0.5 times yung mass ng electron, di ba? Which is again constant 3. Shift, constant 0.3 times V squared. That's alpha B and then squared equals, ayan. Ito yung kanyang kinetic energy. Napakaliit kasi maliit lang yung mass ng electron. 1.6 times 10 to the negative 17. 1.6 times 10 to the negative 17 joules kasi energy yan. For letter C, how long does it take to travel this distance? Ayan. Gaano daw katagal bago narating ng electron yung distance na ito? Kanina sinabi natin na since napakabilis sa kanyang velocity, dapat marating niya yan in a very, very short amount of time. Gamit ka lang ulit ng equations na meron tayo sa kinematics. Ano yon? Vf is equal to Vi plus A times T. So, yung initial velocity natin ay 0, di ba? At ang time ay equal sa Vf divided by the acceleration. So, ang final velocity ay nakastore sa B, fraction sign alpha B. Tapos, yung acceleration ay nakastore sa A. So, alpha A equals, ayan. So, kagaya ng ina-expect natin, maliit yung time. This is 3.37 nanoseconds. 3.37 nanoseconds. Okay? So, that's it. Ganun lang. Madali lang yan. This is the last problem for this episode. So, ano ang nasolve natin mga problems dito sa episode na ito? Natuto tayo kung paano mag-compute ng electric field due to point charges. Kanina may example tayo na isang source charge lang ang pinanggagalingan ng electric field at meron din namang example na dalawang source charges ang pinanggagalingan ng electric field. So, the net electric field is obtained by getting the vector sum of the individual electric fields. And then, the next problems is about the motion of a charged particle in a uniform electric field. Kung saan, ginamit natin yung knowledge natin sa electric fields combined with our prior knowledge in mechanics. So I hope that you would practice solving more problems and find joy while you are doing so. Okay? Thank you so much for watching. Bye!